A warm welcome to everyone. Uh, so today's topic for the webinar is overall equipment effectiveness. This is a tool which is being used by many industries, and so far I have found that this is the only best tool which is relevant for manufacturing and service industries both. Uh, it is a holistic way of finding out the efficiency of any process, be it be service or the manufacturing. So, a brief introduction about myself. Myself, Manish Jain, today's speaker. By qualification, I did my graduation in electrical engineering, uh, and then I did my master's in measurement and instrumentation. I am a certified energy manager from Bureau of Energy Efficiency. I have worked for digitalization of industries. We have been providing solutions in Industry 4.0. And the companies, these are the name of the companies which we have founded. We have been working with Felidae Systems, PM Electronics, and Power Profit Technologies Private Limited. In each industry, each company is dedicated for one particular type of solutions. Felidae System is dedicated towards the automation, and PM Electronics, in this, we are providing machine-based solutions. So we are importing and we are developing machines for certain type of industries, especially the electronic manufacturing industry. And in Power Profit Technologies, we are delivering solutions for Industry 4.0. That's an upcoming area, and we are focused in that. Uh, Before starting my career as an entrepreneur, I have worked with ABB Corporate Research Center, Bangalore. I have worked with Infosys, especially for their automotive and industrial automation consulting projects. I have worked with Infineon. In Infineon, it was dedicated for semiconductors, mostly for automotive and industrial segment. Along with that, I worked with Ray Marine. It's a marine navigation company where I've been involved in developing this marine navigation equipment. Throughout my career before entrepreneurship, half of my career time I've spent in the Europe, where I had an opportunity to work in Germany, Sweden, and the UK. So this is a brief about me. So before we move ahead, let's have a poll about what type of industries we are in. I mean, this will help me in identifying what industries we are targeting right now, and it will help me in understanding you better. So here are the polls. So people who have just joined in, a warm welcome again. And here on the screen, you can see the polls. I just want to know what type of industries you are from. So great. One point here, I just want to let you know, I mean, throughout the webinar, please feel free to raise a question. The problem is when I'll be talking, I may not take the questions right now, but in between, I'll take the questions because the platform does not provide me option of presenting at the same time and seeing the chat box. Right. Okay. So I think we are done with the poll. So thank you so much for participating in the poll. Here are the results. Manufacturing, we have 88%. In services, we have 7% people, and consulting, that's 3%. Great. So today, warm welcome to the manufacturing people. And of course, I mean the service and the consulting people as well. So yeah, and I'll try to make as interactive as possible. so that the questions or the challenges for the manufacturing sector can be addressed. And of course, we'll be taking questions afterwards as well. Right. This is a philosophy of I mean, for manufacturing or any process optimization, we can control what that we can measure. So if we can't measure anything, we cannot control. Can we imagine like driving a car without the checking the speedometer? So we need. I mean, if we have to run the car at certain speed without seeing the speedometer, it's not possible. So that is the philosophy of that. And sorry about that. Yeah. So where this is applicable, I mean, the one we are talking about is plastic and rubber industry, automotive, and FMCG and textile. And these are just some of the industries, but this efficiency or the equipment effectiveness we are going to talk about is majorly for everything. I mean, it's industry agnostic, but we'll have slightly touch on these special industries. Uh, of course, as I said, that this is applicable in the service industries as well. So, what is efficiency? Efficiency is input minus losses, or in terms of that uh, output upon input, right? So what is an output and what input we are giving, and what is output is input minus losses. So we have given input, right? And what we are getting output is what is determining the efficiency, and the output is completely dependent on losses, assuming the input is constant. So efficiency is directly or inversely or negatively proportional to the losses. So less the losses, more the efficiency. And in order to increase efficiency, we have to work on losses. So for example, if you have bought one machine, right? So the cost of the machine is already incurred. What we have to do is we have to find out how we can reduce the loss so that the efficiency can be increased. So, in order to increase the efficiency or effectiveness, we need to focus completely on the losses. So, just another poll, understanding the loss, how we are facing the losses. Okay. So here is another loss, another poll. So please fill what are the major cause of losses. I believe that we most of our attendees are from manufacturing sector, so we must have been facing problems in losses, uh, and we want to know what type of losses we have faced the most. Okay, so right. Thanks again for. I think it's already published, or I don't know. Okay, so here it says that breakdown losses are 66%, inefficiency in workers is 13%, management related is 16%, and we don't know is like, I mean, 3%. So we have basic idea about what are the causes of the breakdown losses we are facing, right? So let's have let's go back to the presentation again. So So here are the basic description about the losses in case of any plant. So the losses are categorized into three major parts: availability loss, performance loss, quality loss. And what is availability loss is for how long your machine was available for you. So all the breakdown is many of the people, I mean, they said that they were facing losses just because of the breakdowns. So we have to identify what was the cause of breakdowns, and we need to make a machine available. And the second is the performance loss. It is more related to the human nature, like minor losses we call technically. So if a operator, or because of the some design defect or anything, so I mean, if the operator is not working efficiently, he takes small breaks, or I mean, there are a little bit of distraction, then these will affect the performance. And quality is also, again, it, of course, I mean, it is dependent on various factors, but uh, even if we are producing, I mean, if machine is available for you for 100%, and your workers are efficient as well, but at the same time, if they are producing faulty product, it's of no use. I mean, it's rather major loss. I mean, it's the loss not only because of the machine time and plant, it's also because of the raw material. So quality loss is something which we have to be very, very careful about. So, in case of availability loss, these are further described into two parts. One is the scheduled loss, and another is the unscheduled loss. In case of scheduled loss, basically, uh, these are sorry, it's basically I mean, please pardon me, these are the unscheduled loss, sorry, these are scheduled loss. So in case of a scheduled loss, we have break time, no plan, preventive maintenance, cleaning, management, meeting, training, and so on and so forth. So basically these are the losses where this is not because of maintenance team, or this is because of any production team. This is because we plan these losses to occur. So, for example, if management decides that that this Friday we'll be having training, so production will definitely not be there, but it is something which people are already aware about, and this will not be counted as a scheduled loss, as an unscheduled loss. So it's scheduled previously. In case of unscheduled loss, so these are the losses which happens unexpectedly. So the major breakdowns, setup change, tool change, adjustment, lack of operator, power failure. So these are the change. These are the losses which occur without any notification. And there could be list of much more losses, I mean, based on the the industry behavior. So we have to identify what are the scheduled loss and what are the unscheduled loss. So now it comes the cycle time. It's a very, very important concept. Cycle time is people say that cycle time sometimes is based on a machine, sometimes it's based on product. What exactly the cycle time is? The time required to produce one piece of product. Now, this unit could be anything. So if suppose it's an injection molding plant, then it could be a number of say bottles which are manufactured in I mean, one manufacturing one big bottle takes may say 30 seconds, or it could be multi cavity cap manufacturing, where say 100 caps can be manufactured in 30 seconds. Now same is the case with the like kg per hour. So there are some manufacturing units, for example, the pipelines, I mean the PVC pipelines or many others, where they measure the cycle time into the kilogram per hour. So they calculate how many kilogram of the product they have manufactured in that particular in 1 hour. And same, there are some measurement unit like meters per hour. So these are majorly for plants like paper, textile, wire. So they measure the cycle time into the meters per hour basis, and kg also, like some units measure in kgs. So here concepts come like there are certain units, like as I gave you an example of multi-cavity injection molding machine. So if you have a cavity of say 50 pieces in an injection molding machine, and you say that your machine can produce 50 caps in 30 seconds, right? But so that means the cycle time of each cap is 30 divided by 50, right? So it's a point 0.6 something second. But that may not work, because your cavities, sometimes you may be running 30 cavities at a time, or maybe 40 cavities. That time it becomes very difficult. So what they do is they calculate the cycle time in terms of the kilogram of material produced. So how do they do that? Like uh, basically, if suppose the weight of a single cap is say 10 grams, and they say that I mean we have a 50 cavity mold, so that means in 30 seconds they can produce 500 grams. So the cycle time of that particular machine will be 500 grams per 30 second. So how we have to check is, like, I mean, 1 gram will be producing 30 divided by 500. So this is what will be the unit. So it varies from industry to industry, and we'll be talking about these units when we'll go into the details. So performance and quality loss. Now performance and the quality loss are completely dependent on the cycle time. And the cycle time is a concept not only for the machine, it could be of product, or it could be a combination of both. So same product you can manufacture in 30 seconds in one machine, and the same product you can manufacture in 25 seconds in another machine. It depends upon the performance of the machine, right? So the cycle time is what define your performance, right? And same is the case of quality loss. In case of quality loss, what we do is, if suppose we have manufactured say 1,000 pieces, and out of that say 200 pieces are faulty, or are of bad quality. So that means if suppose one product takes 1 second to be produced, so we have already lost 200 second in quality. So otherwise we cannot measure the quality loss otherwise. Now, how do we do this OE calculation? Here, I just wanted to give you one idea about OE. Overall equipment effectiveness is a combination of availability, performance, and quality. So it checks how much time the machine was available to you, and then it checks out of the available time what was your performance of your machine. Like when it was supposed to produce say 1,000 pieces, out of that how many pieces it has produced, so that is your performance. And out of pieces you have produced, what are the quality pieces you have produced. So what we do is, in case of OE calculation, we maintain Excel sheet, and each Excel sheet, we have one sheet for each shift. In each shift, what we do is we put data about today's production and today's breakdown detail. So at the end of the month, or at the end of a week, what we do is we consolidate all that information, and it has information about the production, rework, rejection, breakdown as well. So all the information will be filled into the Excel sheet, and then it is you know uh, consolidated at the end of the month. So that's what I mean we do. That's a common practice in the industry. But the challenge of OE calculation using Excel sheet is sharing information is really cumbersome. So now assume that there are 100 machines. So that means each machine will have their own Excel sheet, and each Excel sheet will have say 30 sheets because of each day. I mean, I'm not taking shift into account. I'm just assuming one shift per day. So if there are three shifts, then the number of sheets per month will be 90. I mean, and as assume that there are 100 machines. So managing, consolidating all that data is really cumbersome. The transfer of file is very difficult, uh, because how we do is, if suppose there are 100 operators, they fill their data, and then how, and I'm the plant owner, plant head. So I need to get all that information to my laptop or to my computer. Now, the moment how I can get, either they will send it by email or they will send it by share folder. So, and I have to pull that information and I have to check what is the efficiency. At the end of the day, I will not do anything. So, uh, and of course, even if I try to dig, if I see that, okay, out of 100 machines, these are two machines which I have to focus based on my shop floor staff operation information. If I have to look into this, I can just look into two or three machines performance. But the problem will be like, if I have to find out the overall plant efficiency, that is where I cannot integrate all that information. So I'm going to lack information. And the second problem is, with Excel sheet, there is a enough space or scope of manipulation. So for example, uh, if suppose there is a cycle time of one machine as say 10 second, and if the operator who fills that information and he just makes a change from 10 second to 11 second, right? So the performance will go up, right? And as soon as the performance will go up, the effectiveness will go up. And uh, it's very difficult for me to find out what the cycle time he has filled. I cannot check each and every sheet, right? So the performance will go up and the data is already manipulated. So I will not get the real picture at all. And this is a common practice, believe me. So here is a common scenario, like how this equipment effectiveness model works. There are three main pillars: availability, performance, and quality. Availability is based on planned downtime, setup downtime, and unplanned recorded time. Performance is reduced speed because of manual issues or the minor unrecorded stoppage, which we don't know, and we have seen that some things have gone, and because of which we are not getting. And one example I can just give you is like, we have worked with one die casting unit, and there everything was okay, but the problem was the shots per minute which were expected, it was not coming as per the design of the machine. Then once they started digging that information, it was found the mold design was faulty, and operator decided by himself, even instead of running it, giving the cycle time as 20 second, if he gives for 22 second, it was giving the proper quality. So it was not a problem of the production, it was not a problem of maintenance, it was not problem of any other department which is there in the shop floor. It was the problem of the design department who designed the mold. So these are the points where we can just look into this, and then we can find out who is where to fix these inefficiency. Quality, of course, there are lots and lots and lots of reason why the quality losses happen. So if I give you the same example, if assuming that operator could have run that machine at the same cycle time, and some in between, he could have seen that some rejection was increased because of the new mold. So of course, this will be quality loss. Then it could have been digged, and then we could have found that the problem was in the quality problem was because of the mold. So it's a check and balance. So if even if we miss one point, we can check it another, right? Because these are the sequential operation. So there could be a possibility that the downtime of the machine can be reflected in the quality of the product. So once we have all that information in hand, holistically, then only we can find out what is causing. It communicates from one level to other. So let's go for now to uh, mitigate all this problem of manual intervention and data consolidation. These are the challenges which I mean every industry is having, right? So in order that we let's have a demo. So we introduce a tool called Pro Efficient. Uh, we'll have a demo of this one. So why what is Proefficient? It's a platform. Uh, so what does it do? It's an open architecture. It's a common cloud-based system where all the information, everything is on cloud. We fill that information, we get a report and efficiency report from cloud. It has inbuilt mailing system. It has open architecture so that the data which we are filling in the cloud can be exported to ERP or any of third-party system. So as I said that it can be integrated to your process like emailing the report or submitting the report in your ERP or Google Sheet if you are using. So it can be integrated in any of these system, and then you can fetch your MIS report as usual, right? So you don't need to go for another tool for fetching the information. So you can get it integrated. So the features wise, we in this you have user level management. There is a level of admin, supervisor, and operator. Admin is the one who can see everything what is going on. It's generally of the rank of plant head or the owner, or seen very senior stuff. They can see the report. They can check everything. They are the one who can change some of the settings. Same is the case with supervisor. So supervisor also, what they can do is they can uh, work around with the cycle time if it is required. But operators are not allowed to do any of these things. So operators are allowed just to fill that data of the production of today. So all the information consolidated reports can be seen anytime, anywhere of any machine. So if suppose I'm an owner of 5 plants, whenever I want to see the report of any plant, I can just check the report at my convenient time. The reports can be automated to be delivered to your email every morning or at the end of any shift, or weekly report or the monthly report. So you don't need to ask anyone to provide you the report. User level configurations are there. Shift information. Once we'll go to the demo, everything is configurable. So if you have 2 shifts in a day, 8-hour shifts, a 9-hour shift, or in between, if you have 1 hour break or 1.5 hours break, everything is configurable. Product categorization, cycle time. You can define the category of the product, which is helpful for your further analytics. For example, if you are say a car manufacturer and you want to see the performance of each product, like say engine or brake or anything, so you can get information about your that particular product. And in the product category, we have uh, production labeling option as well. For example, there is a concept of runner, repeater, and stranger. So so these are the category. Based on that, you can uh, program your production line labeling as well. So strangers are the product which comes very often, like once in a month or twice in a month, right? And repeaters are the one which comes more frequently than strangers, but they are more in numbers as well. And runners are the fast most to running product. So production people, they know how to manage these products. So if you have category based on a runner, repeater, stranger, you can plan your production leveling as well. And if there is any problem in your production leveling, this can also be identified. It may be possible that sometimes we qualify some product as stranger, but because of trend, it may turn out to be a repeater. So after seeing the report, you can just see whether I should continue it to keep it into stranger, or I should move it to the repeater, or could be vice versa. So this will be helpful in taking your decision, because uh, uh, for more switching between categories of the product will cause you cost. Machine groups are also like possible. You can group the machines in terms of you know geographical location. Like, I mean, if you decide that this is a shop floor one, where all the machines will be a part of this particular shop floor, or it could be machines for say one particular customer. For example, many tier 1 customers, I mean, they have production line for separate production line for Maruti, another line for Honda, another is for Nissan. So you can categorize machines based on your uh, customer. All right, so let's go for demo. So far, if there is any question, please do let me know. I can just check my chat box. One By the time I read through the chat, let's have one last poll. Uh, just to know at what level of efficiency we are running our plant. So please fill your plant or machine's efficiency. Here you can see this 35, 50%, 50 to 70%, and 70 to 100%, and we don't know. I think Mr. Jayaprakash, I just saw your message. We will share with you this presentation if you want. So if you need any information, we are happy to help you out. Yes, yes, Mr. Verma, you are right. It was my mistake. Pardon me for that. The unscheduled and the scheduled losses got interchanged. So I noticed that. I'm so sorry for that. Right. Okay. So here are the results. We feel that I mean, very low efficiency is somewhere around 7%. 50 to 70% efficiency, people feel that, I mean, 31% people feel that plant efficiency is 50 to 70%, and 48% feel that it's 70 to 100%. Good. So good to know that. So in this, so just a second. Hello. Sorry about that. So so this is I mean, I have just logged in as an admin. So I can see here the master details, where I can add users, I can add product, I can add or delete a machine, shift, stoppage region, and rejection. If you remember, we have discussed about the stoppage region, I mean the losses. So in case of unscheduled losses, each industrial, the company, I mean, they have different type of unscheduled losses. So we have given option of adding your losses as per your company requirement. So one thing here I just want to show you, like for product. Here you can see the product. In this case, what we can, like, I mean, if you have to create a product, the product code is created, the company name is already known, and the product name and the cycle time. Cycle time is the time what it requires. So we have given an option of cycle time as in seconds. So you can create product in cycle time in seconds. Before that, I'll just take you through the machine. We can add machine, and we can group the machines based on your category of shop floor or your customer base. So we can define the machines here, the category, and we can make machines active and inactive as well. So if you have some machines which were there, so that you can make it inactive, but you cannot delete these machines, because sometimes your historical data is very much important. So intentionally we did not make it deleted. We can add into categories. And shift time is also, like, I mean, based on your requirement, you can define your shift, and at particular time you can make any shifts active or inactive. So generally in plant, people have A plus 4, B plus 4. I mean, each plant has their own convention, right? So we can define shifts here, and this will be helpful in, I mean, when we define shift, it we have to fill what is the start time and the end time of each shift. And one special thing which is required is when we are defining a night shift, we have to just define whether it's an overnight shift or not. This will be required for identifying, because especially in this case, the end time of the shift is less than the start time. So we have to define it separately. The start time and end time is defined, and the shifts which are not active, we can make it as inactive, and the shifts which are active, we can just make it active. And in each shift, we can define what are the break times. So so if suppose we have 8 hours shift, and in that, if we have a 1 hour of lunch break, so effective time for me is 7 hours, right? So the tool calculates by itself. So same is the case with the product. So it calculates all the thing. And stoppage region also, as I said, that, I mean, we can add your own. You can add your own stoppage region. I mean, these are basically the stoppage region, like, which are scheduled and unscheduled both. So when we are adding any stoppage region, I mean, we have to qualify whether these are scheduled or unscheduled. So this will be helpful in finding out when we will be filling that information. So here we can just see that, I mean, these are the reason codes, and these are the schedule or I mean, the binary information, whether these are scheduled or unscheduled. And here also we have given our option of any of your stoppage region is active or inactive. Now, once we have done all this, so this is a one-time task. I mean, we don't need to worry much about this because many times we will just add new product. So that is what happening. And when your product cycle time is dependent on machine, so we recommend that it should be a combination of both. So we define, say, product, say, P1 and machine M1 and M2. So this product can be manufactured for on any of these machines. So we suggest you to create P1 underscore M1 and P1 underscore M2, because each of these machine combination and the product will have a different cycle time. So you can identify the performance based on your machine and product combination. Now, how we start filling. Now we have an option. There are two ways. One is like the conventional Excel sheet, what is being filled. We provide a template. So user can just fill and then he can upload the Excel sheet. The data of the production is filled already. And if Excel sheet is not, if one person has to fill, so we provide option of, filling that information directly online. So he can just start filling information about the total production, rework. Total rejection is a not editable part. One thing which I just forgot to show you, the rejection of the product is completely dependent on the category of the product. So, for example, I have say plant of fans, ceiling fans. So there are three parts. One is rotor, second is stator, third is blade. So the rejection region of blade could be different than the rejection region of stator. So we have segregated the rejection region of blade and then the stator. So the moment we change the product category, so the rejection reasons got get changed here. So you can just start filling information. Say 230 is the rework. I did 12 pieces of rework, and aesthetically I found three pieces were faulty. Functional issue there were one. Low efficiency there was zero. So here you can just see that total rejection is already added up, right? So we'll just say that and. Okay, so I've not added the machine. Right. So, so I done. So it's saved into the um, database. Same is the case with the breakdown. So I choose the machine and then the breakdown, and the moment I mean now there is a category of breakdown because in case of OE we need to know the further dig down information. So there could be hundreds of reason of breakdown, right? So what we have to do is we have to categorize the breakdown reason and then the sub reason of each and every breakdown or the downtime. So the moment we choose breakdown, we get like breakdown sub for setup change, and if we change this breakdown, the sub reason is different. So it's completely mapped. So we'll just get the information based on what we have chosen. So uh, here we can just add the time from say 9 to say 10:30. It was under breakdown, so the time is already calculated. This remark we have to fill because this will be helpful once we'll be getting all we'll be filling all that information, and if we want to get report on each and every type of, if suppose into when I'll be analyzing data of my production for last month. So what I have to do is I have to just go for tool change type of stoppage region, and then I can go the list of that, and this remark will be helpful. So because now this is the only subjective thing which is dependent on the user, because user has to fill that information. So we would recommend that he should fill more relevant information. No matter he can fill in Hindi or English or whatever, I mean, he's comfortable in. So that correct information should be filled here so that he can the data can be analyzed. So by that way, I mean, by this way, we can fill all that information on the server. Now, there are two parts of this tool. One is this particular where this information is getting filled by manually, right? And there is an option when we are talking about Industry 4.0, there is an option of getting this information filled directly from the machine. So, and there will be an option of hybrid model, because somewhere we can get information automatically, somewhere we want to fill that information manually. especially in breakdown. Many cases we get the information that this particular machine was under breakdown from this particular time to this time, so we'll get that this information here. So say 9 to 10:30 it was under breakdown. The person has to choose what was the cause of that, and then he has to fill that, because it cannot be identified every time, and especially in case of sub reason or the remark, so user intervention is very much important. And we'll make it sure that uh, it should have, I mean, we throw an alarm to by email at the end of the shift. So by end of the shift, that this information has to be filled. Otherwise, there is no point of filling the information, because we all live in a very short lived memory space. So I mean, I don't remember what I had in last night's dinner right now. I mean, I don't remember. So how will I remember what was the cause of the breakdown and now? So we ask the user. We are also suggest. I mean, we are. I mean, this is under development. We are providing some kind of mobile app. So the operator or the supervisor, he will get a notification as soon as some stoppage is qualified as breakdown. For that, we are deploying some algorithms based on which the machine will be declared under breakdown, and he will get a notification. He will ask the operator, and based on that, he will fill that information as soon as the breakdown is recovered. I mean, the machine is recovered from the breakdown. So that will be done almost in real time, and as soon as so that notification will be very important, and based on that, this real information can be captured. So how the data flow is like, once user fill all that information at the end of the shift, the report is published and it will be sent to each and every stakeholder. So for example, there could be a reason of breakdown. I mean, the downtime because of the quality people, or could be raw material, or could be anything. So the stakeholders could be the production team, could be maintenance team, could be quality team, or could be the purchase team, or the store team. So everyone will get the information out of the breakdown on certain cases. They will get, and they, I mean, in next shift's meeting or next day's meeting, they have to discuss and come to a conclusion that this is what the right thing. Because the major problem in today's scenario in manufacturing plant is a, I mean, I don't want to use this term, but it is blame game. So why we could not solve many of the problem is because we could not find out who is responsible for what. So fixing this accountability is very important. So at the end of the shift, this data is communicated to the relevant stakeholders. They will be agreed on that, and they will get another, say, 8 hours or 10 hours or 24 hours. That is configurable, that within that they can change it. After that, this report cannot be changed. So there will be some kind of restriction applied, and once this is fixed, the report will be pakka. So you can publish that report, and this will be available for the top management, or it can be integrated to your ERP system. So this will resolve the conflicts between the teams, and this will help in more coordination between the team. And so far, like, for by using Excel sheet, or the old way, uh, bringing everyone on the same table is it's a very big challenge. So and 1 hour meeting, many a times it's not sufficient. So but we have to complete the meeting. And actually, I mean, we introduce more inefficiency by doing all that thing. So once that information is coming to everyone's stakeholders email, he can decide if there is any issue he wants to raise. He can raise it and can be consolidated. I mean, there is no need of having a meeting per se for such type of purpose. So we can reduce the meeting time, and this consolidated information will be made as a fixed report. So now let's have a quick view on the reports. So here are the reports, say, from, okay. So here you can see in this report, uh, we have chosen that time. By default, it will be for the current month, right? Uh, so what we see is these are the groups of the machines: shop floor 1, shop floor 2, shop floor 3, and packing area. These are some test data only. So the moment we click on any of the shop floor group, we get the information. So these are the information about the availability rate, productivity rate, quality rate, and overall equipment effectiveness. So these are color coded, again configurable by the user. That we define that more than 75% it will be green, and 75 to 15%, sorry, 25% is orange, 20 less than 25% is red. I mean, we are getting more familiar with this red, green, and orange in considering COVID situation right now. But that is similar to this, so we can identify easily at what level we are working, and uh, here we can just see that because of the productive performance rate or the overall equipment effectiveness is gone down. Now, if we go here in the category report, we see this efficiency, availability rate, product performance rate, and the quality rate on each day and shift basis. We can just check that, and here we can see the production information. So, what was the total production on that particular day, and what was the rejection of that particular day? And here, if I just hover on this, I mean, this is, as I said, that this is a group of machines. We get information about all the machines within that group, and these small graphs are the graphs of the OE of that particular machine for this particular time, 1st April to 31st of May. So here we can just see that how our graph is behaving, and these are all in ascending order. So generally, what will happen if I see on of my one particular shop floor or the group of machines, I found that the efficiency was very low. So I would like to tackle the machine which was causing this low efficiency the most. So this, I mean, we will just see it in the ascending order. So the first one, I mean, I would like to check here. I've already given this. I mean, it was not because of the breakdown of this machine, because availability was 100%. Performance was definitely. I mean, it is something that has screwed up the OE. Quality rate is also not that bad. So why the performance was low? I can just look into this, and the moment I click on this, I get information about this particular machine, and I get all the information about this machine. So here I get efficiency report, production rejection rate, and downtime. This downtime information. One thing just wanted to tell here, you will see information about in Pareto. This particular machine may not have that much information. I'll just show you another machine. Okay, so and this you'll get information about the efficiency on per day per shift basis, uh, the production information on per day basis, what was the production and rejection. Here you can just see the Pareto. For I believe, I mean, most of the people here are familiar with Pareto. Just for for the sake of discussion, let me just slightly brief you. Pareto is uh, the chart based on which works based on 80-20 principle. So like it says that if you work on 20% thing, and if we can get, generally we get 80% result. So we just focus on 20%, 80% here. And what was this is an 80%, and uh, what was causing the 80%? It was mostly the power of and another breakdown, right? So we have to just focus on these things which was causing 80% of the breakdown. And here this is the frequency of the breakdown, which is very relevant because we will see that the breakdown duration was less, but if it is more often, it may cause hindrance in the production. So we have to look into the frequency as well. And this is in Pareto, and this is another way of showing in the pie chart. Here also we can just see what was the major cause and what is the major cause for the frequency of the breakdowns, the downtimes. And we have quality report. This will show what was the major cause of the rejections. So this will show you the rejection information, and here we can just see what is causing the most of rejection. So insulation failure, for example, is 21 out of all other rejection. So we can just look into the here we can give you an option of Pareto also, so that we can find out what was the quality factor which was causing the problem. This is very important. I'll take 5 minutes on this. This is a value addition. So, for example, if one machine was available for you for a month, this is from mostly for the management point of view, top management point of view. They have invested a huge amount on procuring one machine for the plant, right? And they are making it available for 15 days. I mean, suppose we are taking report on 15 days. In 15 days, what was the machine's duration, I mean, for which the machine was with us? So it is 15 into 24 into 60, right? And in that, there are certain time when we had holidays, or we had, no working shifts. So these are the times we have to identify, and this is what we get as 3600 minutes. So effectively, out of 21,600 minutes, 3,600 minutes was the time when I have not allocated this machine to be able to produce anything because of holidays or anything. So this is what is a dead time completely. And after that, I have got total working time as 18,000 minutes, which is actually my factory open time, right? So I have got 18,000 minutes to work on this machine. And in this, I have got another 1,200 minutes, which was caused because of scheduled breakdown, or because of uh, the defined break times. For example, if I am getting say 1 hour of lunch time in 8 hours shift, so 1 hour in each shift, and then for 15 days, if there are two shifts, so it's a 15 into 2, 30 hours into 60, so it is 1800 minutes. So we get this information about the break time based on our break time and scheduled breakdown time. So this is important again from the management point of view. This is where they can see if they can run extra shift or extra day, by which they can recover that, and if they can reduce this break time or any scheduled breakdown. So that's what is important. I mean, here it's very minimal. So I think, I mean, from a management point of view, I may not take, I mean, I may not be bothered, but if it is more, I may, it may be of concern for me. And then this 16,800 is the available time. That is the time when machine was actually there for production, right? Out of any of compliance or breakdown and everything. So but certain plant, for example the glass plant or the steel plant, they run 24 into 60 because they cannot stop it for shift tea time or anything. So they let run. So for them, this is very important. So this is what we have got, this available time for production. And in this, there's a utilization loss. So these are the breakdowns which we call unscheduled breakdowns, which come by surprise. We don't plan for that. I mean, it comes. I mean, it's mostly because of the breakdowns or power failure or unavailability of material, anything. So we register these unscheduled breakdowns. After that, this is the time when the machine was actually running. Okay, so after deducting the time which costed me, availability of the machine, and I have got the machine available for 16,570 minutes. Now, for example, in this, I'm making one product. The cycle time of that product is say 1 minute, and I could produce only say 14,000 pieces. So basically, I have utilized only 14,000 minutes out of 16,570 minutes. So I have lost 2,750 minutes in this minor loss. This could be, as I already said, it could be because of operators inefficiency, or could be minor losses which could not be registered, and as a result we have got less production, and this is what we have lost in the minor losses. We can dig into this, we can find out what was causing that on daily basis as well. And again, after this 14,000 pieces, if suppose I have found that out of 14,000 pieces, 239 pieces were faulty. And since the cycle time of each product is 1 minute, so I have already lost 239 minutes out of that. So what exactly I have got is 13,761 minutes. So if you see here, from 21,600 minutes which was available for that machine for me, so out of that I'm utilizing only 13,761. Now from financial point of view, if I decide, if I amortize the cost of machine for the production team, so I will amortize it for per hour basis, or per minute basis, or per day basis, right? So if I say that, I mean, out of 365 days, this many minutes I have, so you have to pay for this, and out of that I can just see that I could utilize. So what is my payback period of that machine? So I can calculate only based on this value at a time, because that is when machine is actually producing anything which is meaningful, right? So we get this information here, uh, and then we can export this information as a PDF. uh, and as I already said, this is a semi-automatic type of tool where we can add information, as well as the information can be filled directly from the machine. The information will be there, and so each user or the operator or the supervisor, he will be responsible for his own machines, or the group of machines. He can fill that information. He can Supervisor can fetch a report of his own group of machines, but the plant head can fetch information about all the machines in the plant. So it can be exported, it can be sent by email. So that is what, I mean, we can configure. So that's it for this demo. And let me just go to the slide. Just a second. Let me just check if there were any questions. I'm just taking chronologically. Mr. Dilip Dhanar asked, what interface being used to collect and compile the collective information of the facility? As I said, Mr. Dilip, that the interfaces is through Excel sheet, or through manual feeding of the information, or could be directly from the machine. So there are these information, interfaces are available. Yes, Mr. Sridhar, it gives line efficiency as well. Basically, what does it do is we get information in cell-based manufacturing, or the batch mode, or the assembly. So we get information for the line as well. Okay, Mr. Vikas says yes. How much is return on investment in months? Mr. Nanda, this is interesting question. I would say that how I calculate the return on investment is, for example, if I put say plant for say 100 CR, and I know after having more information on this productivity, I can increase the productivity at least by 2%. So I would say that the return on investment is 2 CR out of 100 CR, right? So I mean, if so based on this, the value which we are getting, we can calculate what is our return on investment, return on investment. So a bit return on investment is something which uh, we can discuss based on your performance, I mean, your production. Uh, So coming back to presentation. So we are done with the demo. Uh, Now, one thing which wanted to discuss upon this is, as I said, that uh, the option of deploying this tool is through cloud or could be on premise. So if you have a certain IT department, so we can deploy it in your IT infrastructure. uh, the security is very important when we are talking about making it available. So we provide this 128-bit encryption, all SSL certification and everything, secured connection through which we communicate the data. And there are two type of threats. One is the external threat, for which we put all that encryption and secured connections. And for internal, when I say internal threats are basically internal threat is like if I don't want to share information of certain thing beyond certain level of employee, or like I mean my team member can access this information while he's in the office, or while he's out of office. I mean, he should not be able to see that, or if he's changing anything. So I want it to be recorded. I mean, I don't. I mean, I don't want to be caught in surprise that this is being changed, but I am not aware of that. So we provide virtual private network connectivity as well as the audit trail. Audit trail is a way of uh, collecting all the information of the user if he's making any change or anything. So this will be helpful for the administrator to find out if there was any malpractice practiced. I mean, in the past. So this is the very basic requirement in pharmaceutical industries. They follow this audit trail very much. Uh, so this is helpful in maintaining your data security. We are thinking about, I mean, we do have this stringent password policy. We are also thinking of integrating the hardware key. So when user wants to access, so he has to put some hardware key. So by just remembering the password will not be sufficient. So if he puts a hardware key, then only he will be able to look into the uh, system. Thank you so much. So please feel free if you have any question. Let me just go to that. Or you can uh, have any question offline as well. So let me take the questions. The, the cost of the system, the requirement to implement the system, integrability with SAP. For this, the cost, I mean, we can discuss one-to-one basis. Our technical support team or the commercial team, they will be in touch. So please drop me an message. But definitely, what we look for is the return on investment on these type of solution is very fast. So and it's just not because of the return on investment. Considering the current scenario, when we are all are facing a situation where we have to reduce our cost of production, increase the quality of the production, so that less rework will be required, and we have to identify the areas where we have to improve more. So in order to do that, uh, if we have such tools available where we can take decision in real time or in good time, so these are very helpful. So I would suggest that when we can work it out together when we can sit. So can we do add modification done along with the reason and subreason? Yes, we can do that, Mr. Gaurav. We can do that. This reason and subreason all are editable, and as you said, that it can be used as uh, again, Mr. Jha, the cost is completely dependent on the type of integration you want. Our costing is very transparent. We charge based on the efforts which we deploy, and and SAP integration is, again, I mean, it's dependent on what type of SAP product you are. I mean, business one or some other product. So based on that, we can discuss. But don't worry about the cost. You'll get fast ROI on this. Okay. Thanks, Mr. Vishwaroop. Thanks for attending. I'm not sure if I'm missing some questions. Okay, Mr. Sandeep Doifode asks how to calculate plant OE if we have running number of types of product having different cycle time. Mr. Sandeep, very interesting question. Sorry, I did not cover this information. Uh, so basically, what does it do is we calculate plant efficiency based on what we do is we add the availability of each and every machine divided by the total time available, and then multiply with the productivity of each machine. So basically it's a consolidation of each and every machine within the plant. So each machine has its own contribution. Even if machine is running or not, it has a contribution on plant efficiency calculation until and unless we define that this machine is not active. So if I have certain type of machines which I want, it should not deteriorate my plant efficiency. So I can mark it as inactive so that it will not have any effect, and we can calculate based on the active machines it's a subjective question, Mr. Verma. We can definitely do that customization, but what level customization is required? If there is a very big level of customization, we can discuss it. But if it is a minor, definitely, it may be possible that the kind of customization you are looking for, it could be there as a feature or other configuration, which I may not have covered. So let's discuss offline for customization. Mr. Sridhar asked for a suggestion for improvement. Mr. Sridhar, this will not give complete, direct information about the suggestion, but it will give you pointers where we have to look for. We define in terms of low hanging fruits, the fruits which we can grab easily, and as I said, like 80-20 principle is a very standard tool which works. I've seen which works very well in many of the industries. If we work on these 80-20 principle, we can get result automatically. So we get information which is segregated and qualified for improvement. So we can work on that. So okay, Mr. Kulshrestha, yeah, we'll share the presentation. I think I've taken. Right. So one special announcement here. So those who are interested in evaluating this tool, that is in beta version right now. So those who are interested in, please drop us an email. We'll contact you for demo, evaluation link, and you can evaluate and you can just see how it can help you, and we can have a discussion about that. Can OE be the constraint and numerous other steps of the process? Yeah, of course, Mr. Murugan. Yes, OE can be. I mean, it does not say it's related to manufacturing. It's an overall equipment. Uh, although this equipment means could be the services or the machine. So we can have this constraint analysis on any of the process. Okay, so yeah, Rajini has already put information. So please share your interest. If you want to find out the cost or customization, so we will be in touch. Okay, there is a question from Mr. Kulshesta. Yeah, is this system implemented in India? Yeah, it's very much implemented in India. So we have implemented in. I mean, we cannot disclose the name, but it's already implemented in tier one customer. So so they are using it. We'll be sharing. Okay. All right. So please do let me know if there's any other question. And with folded hand, I am really thankful for you for giving us time, and we are really happy to help you out in case of if we can help anyway. Okay, Mr. Dhandal, well explained. Connect to subject. Does it have the? Yes, yes, Mr. Dhandal. It can be synchronized with SAP, but again, I mean, we need to see what SAP and what kind of information you want to synchronize with SAP. Uh, okay, that I think I mean I've already explained to Mr. Sandeep about the plant OE. I mean that is OP or overall plant effectiveness. So these are the based on the weighted cycle time of each product. So that's how the tool calculates this weighted cycle time. So based on the cycle time of each product, it calculates and weighted and it's an average type of cycle time, and it calculates this plant effectiveness. I think we are done with the mm, questions. So please feel free in case of any doubt or any question. Please feel free to be in touch with our technical support and the commercial team. So they will be in touch with you and see I mean how we can help. Thank you so much for your time and have a nice time. Please be safe, stay at home, and have good take care of your health. Thank you so much.